Hi everyone. In this video, I will tell you about how to make snake and ladder game using data structures and algorithm. This video consists of all the explanation of algorithm, how to construct, how the whole game is done and implemented. At the end, I will explain you about the time complexity as well as explain the code in C language and Python language. The major motive behind doing this project is to learn the implementation of data structure and algorithm. We will learn how to convert a simple snake and ladder game into an advanced version by using data structures and algorithm. Let us move to the objectives. What is the objective of making this game? In the snake and ladder game, the objective is to design a two-player game where player takes turn rolling a dice and moving the respective token on game board. The goal is to find the destination cell from the starting cell using the minimum number of dice thrown. Additionally, the game should provide the shortest path to reach the destination. In short, what is the main functionality of this game as well as the project? The first one is the simple two-player game in which a random dice is generated and the player will move according to that on the game board. The second one is finding the shortest path to reach the destination, and the third one is minimum number of dice throw to reach from the bottom till the end. After that, overview of data structure used. The major role of data structure that are used in this project, the first one is the 2D array. The role of the 2D array, or we can say the matrix, is to make the structure of the board. All the outlines, all the structure of the board is done with the help of 2D array. The role of graph. In the graph, we are using the BFS algorithm that use the data structure queue, and except from that, we are using array list and various other data structure that we will discuss in the next part of the video. So let us go to the stepwise algorithm. The first step to make the snake and ladder game is to create the board. For the creation of board, we are using the 2D array of the struct cell, row, column, and position. This line means like we are making an array that is like in simple matrix we store integer, but in this case we are using structure cell that is having three components: the row, column, and the position. After that, there are some points to notice when we are making the board. The first one is the row start from bottom, not the top. Let us see through the diagram. In normal the game board in the snake and ladder game, we normally see that the matrix always start from 0 here. The row column start from the top end and not from the bottom. But in the snake and ladder game, it is always starting from the bottom corner. So we have to construct the matrix in that way such that 4-0 is considered as the first position, 4-0 is considered as the first position, 4-1 is considered as the second position. So in this way, we will map our matrix so that we can start our snake or start the position from the bottom, not from the top. So after that, the second point is the zigzag pattern. We have to follow the zigzag pattern. For the top thing, like starting it from the if we want to start from the bottom, what we do, we will just start our row in reverse order. Row in reverse order means like we are starting from the size of row, like the number of rows we have assigned. Like if we have given 5 rows, in this case we are having 5 rows, means we are starting from 5 minus 1 as it is a zero based indexing. So that is we are starting from 4 till the 0th index. For following the zigzag pattern, what we do, for zigzag pattern, we just switch the cases. First of all, we will take one flag outside the loop that will switch after we exceed the max limit of column. You can notice from that thing, like first of all, we will start from j equals to 0. This one is j column. We will start from j equals to 0 till the 5. After that, we are moving back, means we are starting from 0 to 5, then 5 to 0, then 0 to 5. Like we are switching, so we can take a flag for this purpose. After that, after creation of board, the next task is the snake and ladder generation. In this game, we are randomly generating the snake, means we just have to input the number of snake and ladder we want. After that, these are going to randomly generate. The snake and ladder, the generated snake and ladder, are again stored in the structure that consists of start and end point. What is the role of this? This will tell the player from which position the snake start till which end. Like in this way, we can easily identify the position of the player when it land on snake or on the ladder. So we will make an array of struct snake and ladder to store the ladder and snake. The next function is mapping function. What is the use of this mapping function? Like what is the role? It is input the position and give you the corresponding row and column. Let us move on the diagram for better understanding. What is the role of mapping function? We are using the mapping function. As we know, we are following the zigzag trend and starting from the bottom. So we need one function that can tell us, like if you input the position, like you write first position, then it will give you the corresponding rows and column as 4-0. This will help you to find out the position of the player in the board. The first position, like if you input first position like 1, it will tell you 4 and 0, like I will show you. The first position stand for 4 and 0, fourth row and 0th column. After that, this is easier one. If you like input the map function 19th position, it will send you back first row and 5th column. So this is the main role of map function. After that, we are having a matrix function. The role of the matrix function is to map the position of snake and ladder according to the position. So the role is to help in the movement of the player. I will explain you that. So this is the matrix. So what is the role of the matrix? The -1 indicate that there is no snake and ladder at that position. If there is anything except -1, this indicates snake or ladder at that position. You can check from this. The ladder and snakes are written here. At the third position, 22 is there. Means first of all, we will how we are storing the snake and ladder. We are storing at start and end the position of snake and ladder. If we have given 3,22, what this mean? This means like at the position 3 on the board, we have to store 22. Means when the player, if player reaches this position 22, from this position, he just moved to this place. This also means from third position, it have to reach 22. Okay, so that's it about the matrix function. So the main, moving further, how to find the shortest path and the minimum number of throws. This is the main logical part of this project, that how to find the shortest path and the minimum number of throws. There are some basic requirements that has to be met before finding this. We need a distance matrix that is used at the end. We will find that it is used to find the minimum number of dice throw. The parent matrix that is used to find the shortest path. We use the backtracking. We just backtrack all the matrix and find the parent of we will find the shortest path by this matrix. And dice number throw, this tells which number of dice is required to make the minimum number of throws. Like if the minimum number of throws are 3, and which are the number of dice required, like 3, 6, the 6 outcomes in a dice. We are having 6 outcomes, out of which this tells us which number is required. So distance matrix we will initialize with infinite. The purpose to initialize this with infinite is like when I check the condition, I will explain you this point why I'll be initializing it with infinity. The parent matrix is initialized with -1, means having no parent in the beginning, and the dice number is also initialized with -1. So what we do, we will start the game from position 1. So in the beginning of the before the BFS started, we will mark the distance at position 1 as 0. You will just not confuse with the term distance matrix. This distance matrix is used to store the steps, like how much steps are required to reach at that particular position. This will tell about that. At the how much step you will reach the position 1, that is 0, as we are initially at that position. So what we do, you have to understand this step. Like in this, we are given the position as 0. Then we will use use the map function. What the map function do, we will give it position 0, and in return it will give us the row and column as the answer, that is 4 and 0. So in the position at the position 4, 0, we will mark 0. Let us see. This one is the distance matrix. What we do, we will at this position we will just mark 0. So after that, what we do, after that we will start our BFS. For BFS, we are required for BFS we need a queue. So we will construct a queue of the size, row and column that stores a pair in simple normal way. In basic queues, we just store the integers, but in this we will make a structure named as pair that will store value and step. What is the value? The value is the current position, and the step is the number of dice that are required. I will explain you by this. In the beginning, as we are enqueue the player, enqueue means adding in the queue. So from the start, 0, 1, 0. What does this mean? This means at the first position, the start is the val, and the step is 0, means 0 number of dice throw is required to reach at the position 1. Now we will apply the condition while queue is empty. In the queue, starting with the BFS, what we do, we will first enqueue in the queue the pair 1, 0 before the loop, that is 1, 0. Oh, sorry, it is not. That is 1, 0. This is the first member. After that, what we do? After that, the current pair is 1, 0. This current pair is 1, 0. We will dequeue the pair and store in the value current. We will make a current pair and we will store this 1, 0 in that and remove the pair from the queue. When we enter inside the queue, we just remove this out. Okay. After that, we will store the num equals to 12. We will make a variable num and store 1 in that, and a variable distance in which we store the 0, the steps required. So let us move to the algorithm. For the algorithm, we have to find the 6 throws. Like for checking the condition and finding the shortest path, we standing at the position 1. standing at the position 1, we have to check all the 6 possible outcomes that are required. Like from the 1, if 1 is on the dice, we reach 2, 3, 4, 5, 6, 7. If the max is 7, if we get 6. So we will apply a for loop from 1 to 6. That is the dice throw, from the outcomes of the dice. After that, we will check the number. The number, what we are having initially is, we are having the num equals to 1 and the distance that we are speaking is 0. So we will use this in the first condition. In the first condition, you will check we are checking the num within the num is within the bound. Means if it is till the 30th position, what is 30? If we say what is 30, we are having the number of rows at 5 and the number of columns are 6. So 6 into 5, that is 30. So we will check that when we add I, what is I? Again, the question, I is the for loops attribute, like I equals to 1 till 6. So we will make a new attribute inside this loop that will add the first outcome, like for 1, 0. For 1, we will add another 1. Means we are having 1 on the dice. The new will become 2. This is second position. And the distance, we know if we throw the dice 1 time, it will increase by 1. So 0 plus 1, that is 1. So we will reach at the distance 1 when we are at the second position. To reach at the second position, we required 1 dice throw. This is the meaning about. So what is this? In this, we just map the position in the map, the function that I explained in earlier part, and get the row and the column. We will get the second position row and column. What is that? That is 4th row and 1st column. We will see from this position. This is. After that, we will check the step. We will match it with the distance array. Initially, all the parent array is initialized with -1. I will just write it out. Initialize with -1, and the parent array is initialized with infinity. So we will check that is the distance we are having. We are having 1 as the distance. Check this condition. Distance plus 1. The distance plus 1 is greater than the distance at row column. What is this row and column? This row and column is the position of the second position's row and column, that is 4 and 2. 4 and 1, sorry. 4 and 1. In the distance array at the position 4 and 1. This is just initialized, means this is having infinity. Initially, we are having infinity here. So we know that infinity is greater than 1. So we will enter this condition. We update the parent array and update the distance array. Let us see how. We will update the parent array as num. The num is 1. As you can see here, the num is 1. So we will write here 1. Sorry, just a second. So this is 1. We will write 1 here as the parent, and in the distance, what we have to do, we have to write d plus 1. That is again 1. Means what this 2, when we fill this, what this indicate? This means the parent of the second position is first, and sorry, a little change. This is -1 here, not 0. 0 is in the distance bracket. So when what does indicate? This indicate that the parent of the second position, like to reach the second position, the parent is 1, and the minimum number of dice throw to reach second position is 1. After that, what we do? After that, the role of matrix come here. We will check in the matrix the position. This is the second position. We will check is there -1 or any other number. If it is -1, then we just simply enqueue the second position 2, 1 inside the queue. But if it is other than that, we will add. This is the next case. I will explain you. So what we do, as it is -1 there, so we just enqueue 2, 1. Let me bold. Okay. So we will enqueue 2, 1 here. After that, I equals to 1 step is complete. Then we have done I equals to 1 here. We will reach the second position. This is I equals to 1. After that, we will do the I equals to 2. So the num remain the same, distance remain the same, the value change here. So we will reach the third position. This will also remain same as it is 1 throw. So the distance is 1. After that, same procedure repeats. We will mark the parent. We will check the num plus I, the new num. This is the new num. Sorry, just a second. I'll just change it out. This is new num. So the new num is this, and after that, what we do, we will check if distance plus 1 is greater than low. At the third position, we are having infinity. So from the infinity, 1 step is better. So what we do, in the place of infinity, we will write 1, and the parent matrix also changed to 1. But in this case, what we see, when we check this condition matrix, when we check at the third position, this is the third position. Right now, we are having 22 at that position. So this case changed. Now what we have to do, we have to find again a new val. We have to find a new val that is equal to the 22, the position, the value at the position of 3. After that, we will find the row and column with the map function of 22 and update the parent matrix according to that. Just see this point clearly. We will check 22 as the new value is 22. Now the parent of 22, from which point we are going to 22, that is third. So 22 is here. So the parent of 22 is 3. Okay, but the distance to reach is 1. This is the main point. Like, this means to reach the position 22, the parent is 3. But you need only one throw to reach the distance 22. Means if standing at 1, you get 2 on the dice, you will directly reach to position 22. The main logic behind is the matrix. Means the presence of you will check there is ladder in this 3 and 22 position. So we will reach directly there. After that, all the steps remain the same. We will check with 3, now what the next step is that we don't include 3, 1. We are not going to include 3, 1. We are going to include 22, 1 inside the queue, as this one is the updated. So similarly, as 22, 1 is added, we will repeat the step when the dice throw is 3, we will reach 4, 1. When the dice throw is 4, we will reach 5, 1. Now again, there is twist with 5, 1. That is not 5, 1. It is 8, 1. Why? Let's do it again. I will explain you the same thing. 8, 1. Why it is 8, 1 and not 4, 1? If the position, this is the position when this is the case, when the new num become 5. At the 5th position in the matrix, it is not written -1. It is written, what it is? It is 8. So we will mark at the 8th position, the parent is 5. What is the parent here? The parent is 5, and to reach, it is 1. So we will just mark it out 1. This is 1, 1, 1, and 1. And the parent is also 1. This is for the third number. Then again 1, again 1, and again 1. This is, I will just explain again. How the parent matrix and the distance matrix, how I make change, I will explain you that thing again. So now what we do, how this, you are a little bit confused how this 1 or 1 came. So we are clear till 22, 1, how this 3 and 1 came. So for 4, 1, this is when the dice throw is, when I is 3. When I is 3, as there is -1, so we don't have to take care of that. So we just put 1 here and 1 here. Oh, sorry, this one is 4th position. After that, in the 5th position, we see that there is a ladder at the 5th position. So what we do, we will just mark don't include 5, 1. We will include 8 here. 8, 1. That means to reach the position 8, this one is position 8, we need one step, and the parent of 8 is 5. Means we have reached 8th position from the 5th position. I thought this much is clear. After that, let us move to the next part. When we start popping out and repeat the same procedure with the 2, 1, there is no change. When you dry run, you will observe that all the things remain the same. This is because when we reach at the 2nd position, we will check that when we reach the 2nd position, the distance there show is 1 plus 1. That is 1 plus 1, 2. But we are having better option 1 inside the matrix, so we don't take that. So 2, 1, we don't have any change with the matrix, so we'll just cut it out. With the 22, 1. When we reach 22, 1, so what we do? We are done with dequeuing 1, 0 and 2, 1 pair. So we will remove it out. Now we take 22, 1 as the next pair. So 22, 1. In 22, 1, we will check the 6 cases. You can check the algorithm, the 6 cases. Now, this is directly the result of the 6 case. 23, 2, represent that to reach the 23 position, you need minimum 2 dice throw. Then 24, 2, 25, 2, when the dice throw means this, when the dice is 1, if the dice is 2, if the dice is 3, 4. And this is 12, 2, as I explained earlier. In the matrix at the position number, we are at the position 27, we are having 12 here. So we don't insert 27, 2 as in the queue. We will update it to 12, 2. So we will add all these things to our queue. After some time, when we reach at this position 24, 2, this will go step by step. I am skipping some iteration in between. So when we reach 24, 2, we will again do these steps. The 6 cases, the 6 dice throw, we will again do that. So we will do 1, 2, 3, 4, 5, 6 till 30, 3. We will add all this in the queue. The time when we reach the position, I'll just type it out. The time when we reach the position 30, 3, there is we will apply one condition in the code. When this one 30 is the position, when the position become greater than equals to 30, 30 is the row and column, this can be anything. If it is 10 cross 10 matrix, then it is 100. When this end reach, we will stop the loop, we will stop the loop, stop the we will not stop it. Like when we reach at this position, that means we have find the shortest path. After that, what we do, the main let me make changes for the array that I have not done. For the 20, this case 22, 1, what happened here is the parent, I am just marking for the 22 and 24th position. I am marking the parent for 24, 2 and 30, 3. So in this position, the 24th position is this. To reach 24th position, we need 2 steps, and the parent of this is, the parent here is 22. Okay. After that, we from the 24th position we reach 30. So the parent here become 24, and the distance here become 3. This is not the detailed iteration. I have done the important one. So to find the shortest path. So now we have the main role plays is parent array. Now we will check the parent array. So now check how to find the shortest path. The main purpose of the parent matrix come now. Let us remove this. So what we do, the parent at the position, we will make a condition like parent in the parent matrix at the last position. Our last position is 30, so I am writing 30 here. Till the position is not equals to -1. This is not position. This is not only position 30. This position will change according to the loop. Initially, we are having the position 30. So we will start from 30 and print the parent. So what is the answer printed? The first one is 30. The shortest path is in the reverse pattern. After that, we will update the parent by the value present at the parent matrix at the position 30. At the position 30, we are having 24. We can see, like, just for a second. At the position 30, we are having 24. So 24, so we will now update this position 30 with 24. We will update the position 30 with 24. Okay, now we will print 24 here. Again, we will update the parent by the value present at the parent matrix. If we will see at the position 24, we are having 22. So now this position turns out to 22. Again, it will print the parent 22. And now check at 22 position. 22 position, what is the parent? 3. So now this is updated to 3. Now print 3. After reaching the third position, we will check at the third position what is the parent. At the third position, 1 is the parent, so we will mark 1. Then now we are going to print 1. Now when we update the parent by the value present at the parent matrix, this is for the initial part, delete it. Now we are having 1 as the parent. At the first position, we are having -1. So the loop will terminate at this point. So that's it. This is the answer. 1, 3, 22, 24 and 30. This is the answer for the shortest path. For the minimum number of throws, that's very easy. You just print the parent at last position at the destination. Oh, sorry, not the parent. The distance at the distance at the destination. What is the distance at the destination? 30. That is 3. Means we require minimum 3 number of throws to reach from the bottom till the end. I will just mark out now. So what is the path it is following? It will first go from 3 to 22, from 22 to 24, then from 24 to 30. For the dice throw pattern, it will print out. You will first require 2 on the dice, then you again require 2, and after that you required 6 here. So that's it about the algorithm. The player game I will explain you in the code. Let's move to the code implementation. So first, before explaining the code, I will show you the actual output that the answer we have dry run and the code has done. We have done what is the output. Let's match that. Just a second. This. First of all, let's match it with the algorithm. So we are having 5 cross 6 matrix. 5 cross 6 matrix. So the rows are 5, column are 6. So we will get to know this is the board. This is the same snake and ladder positions that we have used in dry run. This is the matrix. This matrix is same as this one, the matrix. And after that, we find the shortest path. So when we choose the option 1, we'll see at this point. This is the shortest path we get from the code. 1, 3, 22, 24, 30. And And this one is the shortest path that we get with the help of, this is the shortest path that we get with the help of dry run. So as both the outputs are both the outputs are matches, that means we have done the code in the correct manner. So now let us explain you about the code. I will for the simplification. Wait a second. I will simultaneously explain the C code as well as Python code to reduce your time, and as the logic are same, the language doesn't matter. So let us start. First, what we do, we will create a struct. In the C, we are having a struct. At the same time, in the Python, we are having the class. So what is the function? We store row, column, and the position. Both remain the same. After that, what we do, we create board. The create board function. This one is the C language. In the first thing, what we do, this num1 is for the positioning. We increase it by one step to fix the position as 1, 2 till the 30th. This direction is for this exact pattern. I will explain you. Firstly, we will initialize the board and store the cell's position. So firstly, we will mark all the 2D array with the position 0. After that, what we do, as explained in the algorithm part, we will start the board from the bottom, not from the top. So we will use row -1 to the 0 as the for loop. Then we will use the direction. If the direction is 1, initially it is 1. So we will move from the column 0 to the maximum column. Let me show you again. That means you are starting from this position. You will move from 0 to 5. When the direction switches, when the direction change, you will move from 5 to 0. And in this way, zigzag pattern form and the positions are marked. This line is for switching the position. Similarly, in the Python code, we have done the same thing. We initialize it with 0. After that we have switched the conditions. This and this are exactly same. The logic is the same, just a syntax difference. After that, what we do, after that we have create a snake and ladder. The second step is snake and ladder generation. What we do, we make a struct snake and ladder. This one is the structure for snake and ladder that consists of start and end, and in the Python code for this it is start and end in the class. So how we have generated the snake and ladder, let me show you that code. In the case when what is the major function? This randomly generate the snake and ladder. For the purpose of dry run, I have fixed the snake, but in the question you can change and randomly generate the snake and ladder position. So I will explain you what I did in the for showing the output. This is for random generation. And this is the fixed one. This thing I have used to check my dry run, but in the normal case scenario, we are using a random function to generate the snake and ladder. So this is simple. Just we implement our logic for the start and end, keeping in the mind start and end remain different. We are having different position for the start and end, and mark and store this in the array of structure snake and ladder with start and end position. This is it for the snake and ladder game. This is for the C, and this is for the Python. I again explain, this is for the sake of dry run. I just comment it out. And this one is for the random function. After that, we have done the mapping function. Input the position and give you the output. Where is the map function? The matrix function. The matrix is the map. So what we do, in the matrix function, we are required with, let me explain first. In the matrix function, we need a board. We need the matrix. Sorry, we need a matrix. This matrix is just a structure. This is not filled with value. This is just a 2D array. We will fill it out. After that, this is row, column, and the structure snake and ladder. What is the purpose? This will tell at which position we have to mark the positions of the snake and ladder. Firstly, we initialize our matrix with -1. Don't get confused with this. This is just empty. Then we initialize it with -1 in the beginning. After that, we will check at which position we are having a snake or the ladder. According to that, this is a position. The start is considered as the position, and the value is considered as the end. If we are having 3,22 as a snake, that means at the position 3 we have to store 22. Like, I will show you again. If we are having 3,22 as the ladder, so this means at the position 3 we have to store 22. So this is all about the create matrix function. This remains the same in the Python as well. You can see this is firstly initializes, then we initialize it with -1. The code in the Python is neat and clean and written in a shorthand language, and this one is for initializing in the C language. After that, you will iterate in the snake and ladder. The structure that you have created for snake and ladder, you will iterate and fix the position in the matrix. This will lead to which thing? This is the output for that. After creating the matrix, the next part is this one is the matrix that we have done. The next is the shortest path. I don't spend that much time on the shortest path. the shortest path, this is as same as the algorithm that I've stated and mentioned in the code. The algorithm that I've shown in this algorithm, this is a direct copy of the code. You will just see in this case what the shortest path required. The shortest path needs, first of all, the board, the matrix, and the row and column. It requires start and the end. We know the start and the end. The start is obviously 0, and the end is, if we are we just consider end as row and column, as the row and column can be changed, so we don't fix at 30. So what we do, we will initialize distance, parent, and the dice number. We will first make the array, then we initialize it. Initialize the distance with infinity, parent with -1, and the dice number with -1. After that, what we required a distance, parent. Firstly, we make distance, parent, dice number array. After that, we initialize it. Now, all the thing remain the same. We just create a structure queue. In the C language, we have to make the structure on our own, as it do not consist of any library for the queue. But as same in the Python, we don't require any sort of making a class for queue. We just apply the function queue directly, as we can import the library queue in the Python language. In the C, firstly we create the queue. After that, this one is for the pair. We enqueue and enter the first pair. This condition remains the same as mentioned in the code. Let me minimize this. You can compare this code with this function. This remain the same. The 1 to 6 that I am saying, the outcomes, the dice throw, this is that. The num plus 1 and the row. When we check the number is in bound, this line indicates that thing. The new num and adding, like when we receive the output as 2, 3, and 4, when we add inside, so this is for that. And then we find the position. The new num is the position. Then we map and find the row and column. After that, the same position held. The same procedure is done. D plus 1 greater than distance, new row and column. We will map this one is done. We will check is the current distance in the distance array is less than the distance that we are using, means is like this condition. Initially it is infinite, so most of the time this condition satisfied. If it is less, initially it is infinity, so we change it. After that, we update the parent matrix. The same is done here. And this step for checking the matrix. If it is -1, that means there is no snake and ladder, and we just directly enqueue our pair. But if there is snake and ladder, means matrix in the new row and column is not equals to -1, then we use this procedure, the same that I have done, the 22,1 that I explained in the dry run. In this case, after that, this function, what's the role of this function? As I explained in the end, this is for printing the shortest path, minimum number of dice throw. Here it is 0, 0. Why it is written 0, 0? As our 100th position, it is at the 0, 0 position. You can also write row and column in this place. That's also fine. Not the row and column. The position, the row and column, we first use the map function to find the row and column at position 100. After that, this one is for dice used. You will check the output for that. This print the dice number in reverse order to show the path from start to end. So that's it about the shortest path. For the shortest path in Python language, this remains the same. We take the board, row, column, matrix, start, and end as the input. This one is for initializing distance array as infinity, parent array as -1, and dice number as -1. We will map the position and store it in start, row, and call, and initialize and mark the distance at the position first as 0. As I've explained you, we don't need to make a separate class for queue. We are importing queue, direct library, we import and use it. Then we make start pair. This remains the same. Only the functions that are used in the inbuilt library. .get function, in this we will store in the current variable, we are storing the pair of val and step. After that, we will assess it as current.val and current.step. Okay. The same goes here. The 6 dice implementation, and else the procedure remain the same as the C language. This one is for printing the shortest path. This is for the minimum dice throw, and else all remain the same. So if we want to see till what point we have reached, we first consider make the row and column, build the board. Then this function I have explained, the create board function. After that, we have create the snake and ladder, and then randomly generate the snake and ladder, printing the board, mapping the position. This is just for the sake of try run, and we just map it. After that, this is for printing the snake and ladder, and this is for the mapping. This is for printing the mapping. I just explain you in the output. Let's do the output through. Just a second. You can see here, this one is the creation of board. This one is for the snake and ladder. This one is for the matrix. And now comes, initially this one is printed. Now comes the choices. The shortest path come at the first, so we type first, and this will give us the shortest path. Like from 1, 7, 36. This is the path. This is the minimum number of dice throw. And what are the dice number used? This is about that. Like first you receive 6, then 6, then 6, 5, 6, 6. This is about that. Okay, you must think like why it is 7. This initial value gets stored, so that's why it's 6. You can remove that 6. It's totally fine and it's on you. After that, let's only one part is left, that is the player game. As the generating the random position, we are just calling the function the random snake and ladder. I will tell you about why we are using this. Before that, I just explain you playing the game. So let's move on the player game. So in the player game, firstly we are having a structure named as player. Let me show you first that. The player structure is having the position and the name of the player. That is a character array of 2 words, like we are storing P1 and P2. So this is that. This is 1 and P1, 1 comma P2, the initial position and the name. The goal is printed, and first of all we are giving player 1 as the first turn is given to player 1. This is going to be switched as the direction 1. This is also going to switch. While जितनी देर तक player की position goal के साथ नहीं मिलती, and means the position is not equals to 100 or 30 or row cross column, that is your goal, उतनी देर तक हम randomly generate करेंगे dice. This is a imported function for randomly generating the numbers. This person 6 is for the sake like it choose the number from 1 to 6 only, and plus 1 if 0 come, if random 6 generates 6, so that it not become 0, so it become 1, so that we are using 1 here. So player 1 turn, it will print the name position. After that, in the initial position of the player, we add the dice. After that, we will check that is the player 1 position is greater than goal. If yes, then we just make the position equal to the goal. After that, we will check the row and column. This is just for storing purpose. It is initially having the garbage value. After that, according to the position, the row and column change. For example, in the 5x6 matrix, if we are given the first position, then row and column is 4, 0. This 4, 0 stored in it. Then we will check then we again reuse our matrix. If it is not equals to -1, what we do, we will make the new position in the matrix row. The new position, what is the new position? For example, if at the third position there is a ladder that reaches 22 position, so the new position of the player 1 become 22. Okay, after that we will map it and update the player 1 position to 22 as it reached the ladder. After that, the dice move to the position. This is for the printing purpose, else is for the second player. Both the steps remain the same. After that, we will switch the position, like in the directions, in the zigzag pattern we have done. In this also, as in the direction we have done this. So at the end, when the loop exit and the player reaches the one who is equals to the goal, you can make is that greater than equals to goal, as in some we are also using here the condition, so there is not an issue. So it will print player 1 is the winner and player 2 is the winner. Let me explain you again. The choices are, the first choice is print the shortest path, the second one is to play the game, and the third one is to randomly generate. So the point comes why we are randomly generating the snakes again, as we have done it in the first. So the shortest path, if this shortest path is dependent on the snake and ladder position. If the snake and ladder position remain the same, then the shortest path also remain the same. So if we want to find different shortest path, we have to change the snake and ladder position. So what this is clear with the output. I'll just explain you. Suppose we are having this. This is the randomly generated. This is not the initial one that we have done or dry run. This is randomly generated. So when we option 1. So this is the shortest path, like 194, 88, 82, 76, 70. This is the shortest path. So when we press option 2, so when we choose the option 3, this again change the condition. The player positions get changed and whole this matrix get updated. Now when I press after option 3, option 1, we will get to know that the shortest path is different. You can check, this is 194, 88 and 82, and this one is 196, 90 and 81. There is difference in the shortest path. So this is the purpose of the choice 3, that is randomly generation. So the last one choice is left, the second choice. Let me show you that. This is the simple snake and ladder game. Player 1 turn come, player 1 is at position 1. When the dice is 6, so 1 plus 6, it will move to position 7. In the beginning, P2 and P1 is at the 1st position. So after that, P2 come, P2 is at the position 1. The dice game is 4 and the position become 5. So it will get updated to this. This remains the same till the end. Like you can see, the player 1 is lucky enough. After the player 1 is lucky because at this turn, player 1 is at position 7 and get 2. But at the 9th position, we are having a ladder. So it directly reached to 90th position. After that, it will win. It wins. So this is printed. P1 is the winner. You can continue, or for exit purpose, you can just press 4, and that's it about the snake and ladder game. I hope you all understand about the game. If you want to check with the Python code as well, I will. The implementation remains the same. You will also check. Only this is like I am using 10 cross 10. Now see. all the CLI is same. You can see the board, the matrix, the shortest path remain the same. You can check the outputs remain the same. The player game remain the same. The random generation remain the same. And at the end, you are quitting that. So that's all about the video. I hope you liked it. Thank you.